So I wanted to show y'all about this duplexer we talked about. I've got 2 cans built. We're going to go through and show you how to build this. I got to get the rest of the stuff to get the other 2 cans built. I got to have some more parts, but let's go over it first and let's see how a repeater duplexer works and why do we need one. Okay, for those of you that do not know how a repeater system works, we got mobile A, mobile B, and we got the repeater. Mobile A cannot talk directly through mobile B because its transmit frequency and receive frequencies are different. So to make this work, our repeater here is going to have a receive frequency of 449.000. It's going to have a transmit frequency of 444.000. The mobiles are going to have a receive frequency of 440.0 and a transmit frequency of 449.0. So mobile A transmits to the repeater on 449.0. The repeater receives that on that frequency and turns around and transmits back to mobile B on 444.0. So this increases the range. What a duplexer does is, if you don't run a duplexer and you got your repeater sitting down here, you got a transmitter and receiver. So you got 2 different frequencies involved. Now what some people have done is run one piece of coax up to the top with an antenna and then isolate and come down with the transmit antenna and run the coax to that. Now coax and UHF is very expensive and it costs quite a bit. Plus, you know, that's 2 antennas you got to have, and you got to have these things separated quite a bit. If not, when the transmitter keys up, it's going to overpower the receiver and desense the receiver. So the receiver is not going to be as sensitive as it should be, and this is going to decrease the range of the repeater. So let's get into what a duplexer does. So in your repeater system, you'll have a transmitter and a receiver, and these are your antenna ports. So what we're going to do is have this duplexer. Transmit's going to go into one side and go to the other one. The receiver's going to go to one side and go to the other one. Then they're going to branch off with a T, and then you got an output for one antenna. So the transmit is going to pass the signal and it blocks the receive signal. The same thing on the receive side, it's going to pass the receiver, but it's going to block the transmitter. And that's basically how a duplexer works. I'm not going to get into all the theory. There's plenty of stuff online you can read on how the duplexer works. This is just a basic understanding. What you're seeing here is a signal that's being passed through the AFR 1200, and this signal is going through this. This weekend I started to go ahead and start preparing for the UHF duplexer build. So I'm doing some testing with some cavities. And I think y'all may remember this coffee can from a previous video. So I wanted to show you just what is going on and where I'm at and where this idea came from. So you can see this is not my design. This thing, duplexer, came from the N4GUS Amateur Radio Repeater Users United Society. And it's a 70 centimeter duplexer to designed by Leonard WB3AYW, and this was published on January 29th, 2007. And he goes over details here on how to set everything up and how to tune it up and your parts list. And he'll have various pictures here on the website showing you how it all's supposed to look. I'll leave a link to this down below in the bottom, so if you want to take a look at it and see more about it. He also has a VHF duplexer made from some larger oil cans. So we'll take a look at this heavily caffeinated cavity, which is just only one part of the duplexer. There should be 4 of these built, and I'm still waiting on some other parts. I need one more can, and I'm trying to keep all the cans exactly the same size. You don't want none that's any larger. These are 36 ounce Maxwell House coffee cans, and if you notice there's a T here. Well, I have used up most of my tea, so I ran about 30 miles to a Radio Shack that is still open, which is also a TV place called Thompson TV that sells Radio Shack parts, and they only had 1 tea in stock. So I went ahead and went online and ordered some more. You'll need 5 of these teas. I went to Ace Hardware and picked up a few parts, and you'll see there here there's some brass rod. I picked up 2 brass rods, stock number 135 from Ace Hardware. They're 3/8 by .014, and they're 12 inches long. I picked up 4 brass rods, stock number 133. These are 5/16 by 0.14 at 12 inches long. And as you can see, I have 2 pieces already been cut. You're also going to need some brass nuts, and some brass screws. You're also going to need your 4 coffee cans. Someone else told me that if you go to Lowe's or Home Depot, you could buy 4 1-gallon paint cans. The only thing about the paint cans are going to be about the right diameter. They're going to be a little too long, because a gallon paint can is going to stand up about this tall. So that's more space than what you need. Now if you can figure out how to cut it down short, or how to go in and put a plate in the bottom of it that sets down so that you got about 6 inches or so, you might could use those. But the 36 ounce coffee cans work real good. You're also going to need some number 16 solid copper wire. So you're also going to need a way to connect your coaxes to the cans. This is just a chassis mount BNC connector. You could use end female, that will work fine. Do not use SO239s and PL259s. They do not work that great. Do not make a good enough connection for UHF frequencies. BNCs will work just fine. So you can see here on top of the can we have 2 tubes coming out. The outer tube is soldered directly to the top of the can. The inner tube is slid into it. We'll call that L1. And here you can see our BNC connector. It's plugged in. And now here on the bottom of the can, we'll call this L2. This is a locking nut. There is a brass bolt that goes in, and there's a nut soldered to the can, and so you can adjust this. and then lock it in place. Now the original design, after they tuned the top can, they just soldered the two connectors or two pipes together to keep them from changing. You can also go in and split this on either side and put a small hose clamp around it, and that would hold it steady. So we're injecting a single of 444.4 megahertz through the cavities, and it's just looped through, and we're in duplex mode. So what we're going to do is just adjust the L1 and L2, and we're going to notch out this frequency as low as we can get it. Okay, now we're going to go to our other adjustment. And as you can see, when I go too far, it starts coming back up. Now you know the proper way to adjust any cavity is with a spectrum analyzer with a sweep generator, tracking generator. I do not have a tracking generator. Something I love to get later on is the Rigol spectrum analyzer with the built-in tracking generator, but that's $1,400 down the road, so there's other ways you can get around doing it, but you know, like I say, that is the best way. Now, as you can see, I've just about nailed that down. Go back and touch up the top just a little bit. Okay, and you can see we took our single and it was up at about close to about minus 50 dBm, down below 90 dBm. And what we're doing, we just set this can up to reject the low frequency. So to get this set up, we find the center of the can, and we're going to punch a hole in the center. We're going to come 1.5 inches in the center of that hole, and we're going to punch another hole, and that hole is going to be for our BNC connector. Down on the side, away on the opposite side of the BNC connector, we're going to come from the bottom of the can, we're going to measure up 2 inches, and we're going to pop another hole, and that'll be for our fine tuning adjust. So I have all 3 holes drilled. This one I went just a little bit oversized. It's always best to use something like a step bit, and for some reason I used a regular bit and got it a little bit oversized, but that's alright. Also the hole down in the side here for the fine tune, you'll need to remove all the paint around it because you're going to need to solder a nut to that. So if you take one of the larger tubes, which is the 3/8, you want to cut it down to 4 inches. So I have a larger piece cut down to 4 inches. Now the inside piece that slides in it, this should really be a very tight slip fit, but it's not. There's some play in it. Now the part that goes into the can, like I say, 3 inches are going to be inside the can, and it's going to adjust in and out. It doesn't matter about the top, because what we're looking at is getting the length from the can, top of the can, which is actually the bottom, to the bottom of this capacitor. You need a good seal here, and I'll show you how we're going to do that. I'm just going to go here about 3/8. Draws a line around the end of our tubing. Then what I did was went around and I cut 4 slots. It's just in a cross configuration. Now what we're going to do is bend these in just a little bit. And this is going to act like finger stock. And it's going to tighten up on that inner tube. And should make a good electrical connection. And you just form it around. Yeah, we have closed the end up of it. Now our rod will go in. Yep. And that makes a real tight fit. And being brass, it's not going to come loose. It's going to stay just about where it's at. So another thing we're going to do is come from the other end, and we're going to mark 1 inch around the tube, and that's how much is going to stick out at the top of the can. So this is going to go in place about right there and solder in. But we got to remember, we want to keep this pretty much straight. And the easiest way I found to do it is take an extra layer to the bottom and go right in the very center and drill a little small hole. We'll put the lid on. We'll take our inner tube and we're going to slide into it. And that goes right through the bottom. So now that we got our tube in, we can just go around here and we'll flux this up and solder it in place. So now that is all soldered in. Just got to clean that flux off. We'll go ahead and get the BNC connector installed next. Okay, well, BNC connectors installed, and now what we need to do is make the pickup to go on this. And we'll do this by taking our number 16 wire, and we're going to need a piece that's 2 inches long. and we'll need a piece that's 4 inches long. So we'll start by taking our 4-inch piece of wire, and we're going to bend it starting at a 1/4 inch in a 90. Just like that. Then we're going to go 3/4 of an inch and go opposite that bend into another 90. Like this. So we're 1/4 inch with 3/4 of an inch. Now we're going to measure 1 1/4 inches. From that mark, let me get some small files. And what we're going to do is bend this at a 45 degree. A little bit too far. Yep, that looks about right. Now we're going to take our little 2-inch piece, mark the center, and we're going to bend that into a V. Like this. So you can see how we sorted this together. I just took our 4-inch piece, stuck it in a hole here in a 2x4, and then sorted the V onto the back of it with the 2 points of the V pointing in, so it's like an arrow pointing out. Alright, so I wanted to show you this before I sorted this in the can. I've sorted to a BNC connector temporary. As you can see, this is going to sit in there and the lead will be right here. The tube inside is going to sit right next to this pickup coil. Just like this. Inside. So I just want to give you a visual of it before I sorted it in place. So I have that sorted in place now. See if I can zoom in there on there. You can see it. You want it angled directly to the center capacitor. Alright, now it's time to install our fine tune. So the way I like to do it is put it in backwards. I put a nut inside and a nut here on the outside. Flux around there, and I'll go ahead and get that soldered in place, and this way the bolt and the two nuts are held in place, so I can go ahead and solder it. So we've got our nut soldered in place, and our bolt is installed into it. So what we're going to do now is okay, I've got a jam nut installed. Now what we're going to do is put another nut right on here, and I'll solder this one in place so it'll give us a good way to tune it. So what we'll do next is cut out a piece of aluminum foil, and we'll just line that inside the lid. You gotta use spots that's not covered. Just press another piece in. Then we'll take our can, set right down on the lid. Go ahead and take this shaft, screw it all the way in. Alright, and we'll need to cut this rod off just a little bit so it ain't sticking so far out. Okay, so both cans are installed. I had to use a PL259T on this one because, like I say, I've got some of these BNCs. Never use these, they're just too lossy, but this is just for showing purposes only. So if you're looking at the IFR, both cans are completely detuned, and you can see we're about minus 40 dBm, and what we want to do, we want to reject this frequency. So we're going to tune to these, and it'll take me a little while, but see just how far down I can get it. Well, that's pretty good. I can barely tell that there's a little bit of a single left into it. Look right down that center graticle, and I'll detune to fine just a little bit, and you should see it come up. If you go the other way, it starts coming back up. Okay. I hope y'all saw that. I wasn't looking at the camera. Okay, after playing around with it for a while, as you can see, there's barely any single at all. I can tell where it is. I can just just see the blip just a little bit. I'm gonna detune just a little bit, and you can see the spike come back up. We'll go back down with it. We'll keep turning, coming back up, and back down. Okay, let's check our transmit frequency. Okay, I got the transmit frequency plugged in, and I'm going to go up on it. Nice single going in. So the can is passing the transmit, but is rejecting the receive frequency. and that's with both cans in series. And you got to remember now, I'm not using double shielded coax for this, which is what I really need to be doing. I just got to make up some cables, but I just want to give you a rundown on how this is coming along. So I hope you enjoyed that little demonstration and showing you how to build this UHF cavities. When I get the rest of the stuff in, I'm going to do some more testing and see if we get it fine-tuned, and we'll go over it and do a tuning on it when we get all 4 cavities built, and see how it does. Maybe by this time I'll have the UHF repeater up and running so we can do some on-air testing. Anyway, I hope you enjoyed this video, and I hope you found it, but more further testing will be needed to confirm this. Anyway, we'll catch you next time.